Okay, so for 8.2, we are going to be looking at what we call the measure of center, and we're going to be able to determine, after we learn what the measures of center are, which is a better choice for a given data set. So 8.2, we're going to determine the best measure of center for a data set. So let's take some definitions first. Statistics. You guys have heard of statistics, but here's the actual definition. Statistics are the numerical characteristics of a data set. So there are different types of statistics that we can take and that we can look at. What we're going to be looking at today is called the measure of central tendency. The measure of central tendency are the numerical values used to describe the overall clustering of data in a set. So where the data is clustering most around, whether that's in the middle, to the left, or to the right. There are two types of measures of central tendency that are common. The first is the mean, or the average. The mean is the sum of the data values divided by the number of values, which you guys have actually been doing since elementary school. There is a notation used for the mean, so a different type of way to represent the mean, and that is an X with a bar above it, and if you were to read that, you would call it X bar. So X bar is the mean. The second measure of central tendency that we're going to be using is the median. Median is the middlemost value of the data set, so it's the one right in the middle. So example 1. We are going to calculate the mean of the sugar amount per serving in the different cereals. So using that chart that we've been using the past couple days, we're going to calculate the mean amount of sugar per serving. So we're going to call that X bar because that notation means the mean. And we're going to add all of those sugar amounts up. So 13 plus 4 plus 11 plus 7 plus 10 plus 10 plus 7 plus 7 plus 8 plus 6 plus 7 plus 5 plus 12 plus 5 plus 4 plus 3 plus 4 plus 1 plus 22 and plus 11. So we're going to add all of those up, and we're going to divide by the number of cereals, which was 20. And you guys can use a calculator for this, so don't worry. So doing that calculation, if we were to add all of the amounts of sugar per serving, it comes out to 157. And remember, we're going to divide that by 20. And when you divide 157 by 20, you get 7.85 grams of sugar. So our mean, or the average amount of sugar in each box, is 7.85 grams. Example 2. Example 2 wants us to determine the median sugar amount in one serving of cereal, and then interpret its meaning in terms of the problem. So same thing, we're going to list all of the amounts of sugar, but you want to list them in numerical order from smallest to biggest. So that's going to be 1, 3, 4, 4, 4, 5, 5, 6, 7, 7, 7, 7, 8, 10, 10, 11, 11, 12, 13, and 22. And then to find the median, you can count inwards. So if we go one on front and one in back, then the next one, next one, next one, next one, Next one, here, here. Okay, so we ended up with 2. So because those 2 were both in the middle, we take the average of those 2. But 7 and 7, their mean comes out to 7. So our median is 7 grams. So that means that half of the cereals have 7 grams of sugar or less. Because here is our median at 7, and so half of those have less than 7 or at 7. Okay, per serving. So that's what the median tells us. The mean tells us what the average amount for all of them are, and the median tells us exactly where half of them lie. So half of them are less than 7. So if we go to example 3, this is the box and whisker plot that we drew yesterday for our amount of cereal. And all they want us to do is label the mean and the median and which measure best represents the data set. So in our box and whisker plot, the median was 7. So right here is our median. Just draw an arrow to it. And our mean is 7.85. So that's between 7 and 8, but a little bit closer to 8. So I'm going to put a line there, and I'm going to label it the mean. So if you notice, they're really close, but the mean is greater than the median. So make sure you write that. The mean is greater than the median. But if you notice, our data is really skewed because 75% of our data, remember, is at 10 grams or less. So most of our data is clustered on the left side. So if we're trying to represent the amount of sugar that's most likely in a box of cereal, either between 7 and 7.8, if you notice, half of the cereals have 7 or less. And the mean tells us that on average, the cereals have almost 8. So because the data is so skewed to the left, skewed to the right, most of the data is on the left. Because it's so skewed, our median is a better representation of how much sugar is likely to be in a box of cereal. So let's write, because the data is skewed, the median is a better measure of how much sugar is the most likely amount. Okay, so once again, because our data is so skewed to the right, meaning most of it lies on the left side of our chart, the median actually gives us a better representation of about how much sugar you're going to find in each box of cereal, because half of the data is less than or equal to the median. The mean is greater than the median, and is actually kind of telling us that on average most of the boxes have more sugar than they actually do. So, and that's because we had that outlier of 22 over there. So the mean, when your data is skewed, the median is a better representation of a measure of central tendency. So now let's look at a histogram. Example 3. And we want to identify which measure of central tendency would be the most appropriate to describe the data. And we want to determine the mean and the median if possible. If not, we'll explain why not. So in this histogram is measuring how much rain the city of Collinsburg is getting. And your bottom represents the amount of inches of rain. So between 0 and 1, between 1 and 2, 2 and 3, 3 and 4, and 4 and 5. And then this is telling you how many months received that much rain. So the months that received between 0 and 1 inches of rain, there were 3 of them. There were 5 months that received between 1 and 2 inches of rain, 8 months that received between 2 and 3, and so on. So if we look at our histogram, this looks pretty symmetrical to me. It's not really skewed one way to the left or right. It's pretty symmetrical. So because our data is very symmetrical, the mean is actually going to give us a really good representation of central tendency and how much, on average, rain we received. So the measure of central tendency that would be most appropriate would be the mean, because the data is symmetric. So let's write that. Mean is a better measure of central tendency because the data is symmetric. Okay. Then it wants us to determine what the mean and median is if possible. Histograms, remember, only give you how many months, students, people fall within certain intervals. They don't actually give you exact numbers or exact pieces of data. So it's not possible on a histogram to determine the mean or the median because we don't know what the exact points of data are. So let's write that too. You cannot determine the mean because the data is organized in intervals. Okay, so on a histogram we can't determine mean or median. We can just tell you which one is a better measure, but we can't tell you the exact. So let's look at the same type of question, but this time on a dot plot. So on example 5, I'm giving you a dot plot of the number of gold medals won in the Special Olympics. And so this is saying that 2 people won 0 gold medals. 1, 2, 3, 4 people won 1 gold medal. 3 people won 2 gold medals, and so on and so on. So if we look at our data, I'm noticing that there is a lot of data that's kind of focused right here on the left and not as much over here. So this is definitely skewed to the right. And because our data is skewed, the mean is going to give us something around here, but our median is more off to the left. So median would be a better measure of central tendency. So median is a better measure of central tendency because the data is skewed right. Now, on a dot plot, they actually do tell us exactly how many people got 0 medals, how many people got 1, how many people got 2. So we can calculate the mean and the median. So to calculate the mean, you are going to take all of the numbers of each of the number of medals won and add them all up and divide by how many dots there are. So we have 0 plus 0. So bar x, or x bar, the mean, would be 0 plus 0 plus 1 plus 1 plus 1 plus 1. There are 3 2s, 1 3, 2 4s, 2 5s, 2 6s, no 7s, no 8s, 2 9s, a 10, and a 14. So you're going to take all of those and then divide by how many participants there were, which was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And do that math for me really quick. So you should have got a mean of 4.25. Now our median, we already have everything listed in order, so you're going to count inwards. And if we count all of the way inwards, we end up right here. 3 and 4 are both right in the middle. So we have to take, because there was 2 of them, you have to take in between those 2 numbers. So in between 3 and 4 is our median, which is 3.5, which should make sense, because if we look at our data, at our dot plot, around 3.5, most of the students earned around 3.5 to 4 medals rather than 4.25. So median is a better measure of central tendency. And that's 8.2.